This is translations. Yesterday I went over reflections. A reflection is a flip across a line. A translation is a slide. It's when you slide an object. Alright, so we're given a vector or a rule. So the vector 2, -1 is the same thing as writing it as a rule, and it's the change for each point. And a vector is written in the same manner as you write a coordinate point, except for the parentheses are a little different. You see how they're kind of pointy on the edges, like kind of like arrows? Those are vector parentheses, but it's still xy. So this 2 is representing the change in x. It's a +2. We know positive x values are to the right. And then the y is a -1, so we know if we're going to do -1 in the y values, then we're going to go down 1. And that's the same thing that's happening when it's written as a rule. This is down 1 or right 2. And you can see that's happening by just picking a single point. Like from C, if I go to the right 2 spaces, and then I go down 1 space, then I end up as C prime. And so technically the vector is the direct line. It's this distance. We're not getting into all of that. But the 2 components that make up the vector are the horizontal and the vertical distances. They're blue and the green lines. And then the vector itself is the red line. If you take physics, you'll get into that. But we're looking at writing it at how it's changing the whole figure. So every single point has been moved to the right 2 and down 1 space. So we're going to do a couple of those. Here we have quadrilateral T, U, V, W. So we're going to plot those points. And the scale on this graph is weird. So it's counting by 2s. So all the odd numbers are just kind of in between. So we have -3, -8. So here's -3 and -8 is right there. And then that's T. U is at -6, +3. So -6 and +3. V is at 0, 3. And W is at 3, 0. You should be able to see that there is a quadrilateral. It's just a 4-sided figure. These are supposed to be straight lines, but I'm not the best at making straight lines. There you go. And it's going to be changed by the vector 4, 5. So again, the x value is a +4, so it's going to shift to the right 4 units. And +5 for y means each point is going to be shifted up 5 units. So we can do that 2 ways. We can do it graphically, or we can do it algebraically. I find algebraic being the better method. The method less likely to make mistakes. So for all of these points given, I'm going to take the change in x, the 4. I'm going to add 4 to all of the x values. And then I'm going to take the change in the y, 5, and I'm going to add 5 to all of the y values. And that will give me the result of T prime is -3 + 4, so that's 1. -8 + 5 is -3. U prime, -6 + 4, that's -2. 3 + 5, that's 8. Then V prime is 0 + 4, that's 4. 3 plus 5, that's 8. And then W prime, 3 plus 4, which is 7. 0 plus 5, which is 5. So then when I plot these 4 new points, I should end up with the same shape. It's just going to be moved to the right and up. So T prime is at 1, -3. -2, 8. That is U prime. V is at 4, 8. And W prime is at 7, 5. And then connect these dots. I could see that I do have the same shape. It's just every single one of them has moved. Oops, wrong color. Up 5 units and to the right 4 units. Okay. That is with a vector, given the vector. The next one is really the same thing. It's just you're given a rule instead of a vector. It's just giving you the information in a different format. So here we have triangle QRS. So again, I'm going to plot the points QRS. So 2, 5, that's Q. 7, 1 is R. -1, 2, that is S. So there's my original triangle. And this time I'm given a rule. And I know x minus 1. So if I'm going to take the x value and I'm going to move it 1 in the negative direction, then it's going to go to the left. And for the y's, if it's -2, that means I'm going to shift all of the points down 2 units. All right, I am going to rewrite these points because they're not as convenient as the last problem. So I'm going to have point Q at 2, 5. R, 7, 1. I'm just rewriting what was given in the problem. And S is at -1, 2. And then I'm going to subtract 1 because it says x minus 1. So what that rule is saying is the point xy becomes, which is the arrow, it becomes x minus 1 and y minus 2. So we plug in the value of x, which is 2, and then say minus 1. And then y is 5, and then minus 2, and that gives us the new Q point, Q prime. 2 minus 1 is 1. 5 minus 2 is 3. For R, same thing. Subtract 1 from the x's and subtract 2 from the y's. So 7 minus 1 is 6. 1 minus 2 is -1. That's the coordinates of R prime. -1 minus 1 is -2. 2 minus 2 is 0. And that's the coordinates for S prime. So then I graph it. 1, 3. That is Q prime. 6, -1 is R prime. And -2, 0 is S prime. So again, I have the same shape. It's just been shifted down and to the left. This is a translation. Just make sure every point changes in the same amount. And then on the back I have some other examples that are a little different. This time you're given the graph and you're asked what is the translation vector. Since it's saying vector, I know this is going to be something that looks like this. Alright, so for the first one, I'm going to pick a point on the figure. It says from figure 1 to figure 2. And I'm going to pick the corresponding point on figure 2. So I picked the bottom right point on figure 1. I could have picked any point on figure 1. It doesn't matter. As long as you pick the corresponding point on figure 2. And to get there, you have to go to the right, and then you have to go up. We're counting by ones. Those other graphs were a little weird because they were counting by twos. So 1, 2, 3, 4. That was 4 spaces to the right, so that's a positive 4. Up 2, so it's a positive 2. So the vector is the vector for 2. That describes the translation that happened from figure 1 to figure 2. So then if I look at from figure 2 to figure 3, again, pick a point on figure 2, pick a point on figure 3. I could use the same point. It doesn't matter which point you pick. I changed points just because I don't have anything overlapping if I do it this way. Alright, so I'm going to go up 1. And then, so that's 1. And then I have to go to the left. So if I go to the left on the x-axis, that's negative, right? So 1, 2, 3, 4. Means I have to go left 4, so that's going to be negative 4. And you always go xy in the order of xy. So the vector is negative 4, 1. And then one more. From figure 3 to figure 4. I'm going to choose the top left corner of figure 3 and the top left corner of figure 4. So to get from 3 to 4, I have to go up and I have to go right. So these are both positive directions. I'm going up 1, 2, 3 units, and I'm going right 3 units. So the translation vector is 3, 3. All right. All right, so on number 4 and 5, 4, 5, and 6, really. Word problem, it's more vocabulary. Translating a pre-image point, so the original, 3, 6, negative 6, along the vector negative 1, 4 results in what image coordinate? So it's just, where is the final point? We're given the point 3, 6, 3, negative 6. So I have the point 3, negative 6. And then I apply the vector. Negative 1, 4. So minus 1 from the x, plus 4 to the y. And the result that I get is 3 minus 1 is 2. Negative 6 plus 4 is negative 2. So that is the image. The image coordinate is at 2, negative 2. We have another one, but this time it's a rule instead of a vector. Again, it's the same thing, really. This time we have it written as a rule, but it's the same type question. You take the pre-image. So we have 4, 8. Apply the change, apply the translation. So x plus 3, so I'm adding 3 to x, and I'm subtracting 3 from y. And the result is the image. So 4 plus 3 is 7. 8 minus 3 is 5. So that is the image. One more of these. This time it says translate the point, negative 6, 3, down 5 units and left 3 units. What is the vector used? What is the rule? What is the new coordinate? So I do need 3 things. This time so I'm going to start with the point, negative 6, 3, the pre-image. I'm going to apply the change. The change is down 5 and left 3. So these are not in XY order, right? Down 5, that's Y. So the negative 5 has to go to the Y. Left 3, that's the X change. It's on the X-axis, left and right's X-axis. If I go to the left, that's negative X's. So minus 3 to the X's. And then to get the resulting coordinate, negative 6 minus 3 is negative 9. 3 minus 5 is negative 2. So the image is negative 9, negative 2. And then it also asks me, what is the vector? Well, that's the change, right? Written with vector parentheses, negative 3, negative 5. And it says, what is the rule? So the rule is the same information, but given as the point xy becomes x minus 3, y minus 5.